Hello everyone. Today we are going to explore an exciting concept, the law of conservation of energy. Let me start with the questions. Where does the energy go when you swing on a swing or slide down a hill? Take a moment to think about it. The energy doesn't disappear, it transforms. By the end of today's lessons, you will understand how energy works and how it changes from but never gets lost. Let me explain using presentation. Let's begin energy and conservation of energy. Today you will describe the law of the conservation of energy, explain how energy can be transferred, use examples to explain energy transfers. Capacity to the work or it's fundamental to all natural and powers every activity, including our house, enabling biological function. Kinetic, potential, elastic, thermal, chemical, and nuclear. Kinetic energy is kinetic energy is the energy that object passes to their motion. Formula is kinetic energy 1/2 meter v square, where m is mass. V is velocity, is kinetic energy, is key. Characteristic increases with mass and the square of velocity. Always positive motions cannot have a negative energy. Examples: a moving cars or falling object, one turning the blades of one turbine. Potential energy formula is Pe equals mgh, where m is mass, g is acceleration of gravity, h is high, Pe is potential energy. Characteristic depends on position of state, can be stored energy. Examples: water stored in a dam, stretched rubber band, a book placed on a shelf. Energy efficiency and losses. The ratio of useful energy output, the total energy input, the energy efficiency formula, energy output divided energy input. Times 100 equals efficiency. Energy losses. Energy is often lost at heat, sound, or friction in systems. Example: car engine lost energy as heat combustion. What happens to energy? Energy is never created nor destroyed. It just transferred between different stories of energy. This is known as law of conservation of energy. The total amount of energy in a system, the total energy stored before equals the total energy stored after. How can energy be transferred? Energy can be transferred from one store to another in four ways. First, mechanical work. This is happens when a force is applied to move an object through a distance. Example: lifting a box. Second is electrical work. It involves changes moving in a circuit due to a potential difference, powering a toy cars with battery. Third is heating. It involves the transfer of energy from a hotter object to a colder one. Example: melting cycle. Radiation. Last one is radiation. It occurs when energy is transferred as a wave, such as visible light or infrared. Example: warming of pigment in the daytimes. Where questions, learn and check. Answer the questions. Can you identify the type of current and following examples? Where two pictures is mechanical works. First is elastic potential force of the spring, gravitational potential store of the ball, kinetic store of the ball. Second questions: suppose a ball at the height of the net is 100 joule of gravitational potential energy. How does the ball of its change to fall? First, that the ball and height of the net has 100 joule of gravitational potential energy. Second, as the ball falls halfway, it has to 50 joule of gravitational potential energy and 50 joules of kinetic energy. Third, right before bouncing on the floor, the ball has a gravitational potential energy, but it has 100 joule of kinetic energy. And review energy. Energy is neither created nor destroyed in trees. It is transferred from one store to another. Energy transfer. Energy can be transferred in four ways: electrical, mechanical, radiation, and by heating. Uh, Quantifying energy. We can put numbers to the amount of energy something has started. Unit of energy is a joule. Joel, and thank you for your attention. Uh, Second, next we for presentation, let's test your understanding with a quick game. I will give you cards with terms and definitions, and your job find the matching pair. Matching pair. This is Blackboard, five terms and five definitions. Kinetic law of conservation energy is energy cannot be created or destroyed, only transformed. Is a chemical, thermal, and a mechanical. Hy- uh, Hydropower plant potential kinetic and electrical energy. Energy transformation is chemical, thermal, mechanical energy. So 4 points. And the second, let's move on to the short quiz to test your understanding. For presentation, first, where is 5 questions. Presentation for our lessons, our week. Um, uh, what are questions? Oh, quiz for presentation. What is the formula kinetic energy? Kinetic energy formula is this Ke equals 1/2 mv square. And as an example, potential energy is water stored in a tank. Third, in the formula Pe equals mgh, what are reference points? Last, what type of energy transformation occurs in the hydropower plants is a thermal potential. The last one, which of the following describes the law of conservation energy? Energy cannot be created or destroyed, only transformed. And we're finished is quiz and matching flyer, and we next work do lab work. First is lab work. Lab work. Where a lab work name is lab work. In this pet energy skate park simulation. Where objectives objective to explore the relationship between kinetic energy and potential energy, to verify in the contract and understand how energy transfers between kinetic and potential energy at different points during materials and work procedure. And we fill in the table with the high kinetic energy, potential energy. We're done given 3 points, 5 meter, 2.5. We can data analyze how potential energy decreases and kinetic energy increases, and the skater moves down the track, and we can write conclusion. First, and now let's bring in the concept of life using the pet energy skate park simulation. I will demonstrate it first, and then you will have a chance in pairs. First, watch where coordinate this kinetic, potential, and thermal and the total energy. Where in table given 5 meters and kind of energy that's scattering half. Where this is potential energy, and if decrease and kinetic energy increases. Let's see is a worksheet to work that the energy change work with the your partner. We can fill the table. Fill the table. Discuss our finding. Finding what is the notice about the total energy in the system. In the system. Conclusion to warp up, remember that energy doesn't disappear, it transforms, whether it's kinetic energy or potential energy. The total energy is closed system remains constant. This is the law of conservation of energy. For homework, I'd like to solve these three problems. Introduction, where done introduction, complete the following task at home, show all calculation and the right explanation where required, submit your work nearly on paper and electronical, and the second task for homework explanation on how the law of conservation applies to a real-world scenarios such as a roller coaster, a boulder dam, a swing pendulum. Thank you. Open lesson. Your feedback highly valued and will help you teaching. Teaching methods. You are welcome to share Mentimeter platform using the following QR, where we can screen QR and write feedback. See you next class. Мало шықты, бәләйін. Неге? Білмеймін. Шығарып жүрді. Ол өзі жасамады. Мен жарыстан кейін шығарып жүрді деп қаламын болды. Содан кейін шығып кетемін. Екі минут өткен шығып қалды. Содан кейін